We're going to solve equations that have logarithms in them by using a method I like to call squish, switch, and solve. The first part we'll work on is the switch, because sometimes that's all you have to do before solving. You need to be able to switch from logarithmic form to exponential. Remember that log base 2 of 8 equals 3 because 2 to the third equals 8. So, log base 4 of 2x squared equals 3 could be switched into 4 to the third equals 2x squared. Log of x over 6 equals 2 can become 10 squared equals x over 6. Or we can switch natural log of the group x minus 5 equals 2 into e squared equals x minus 5. That's one step of our solving strategy, the switch to exponential form. If you have a single log expression on one side of your equation and a constant on the other side, switch. Let's go back to the example that I wrote before, log base 4 of 2x squared equals 3. We're going to switch to exponent form, so that's 4 cubed equals 2x squared. And now we're going to solve. 4 to the third is 64, and if I divide both sides by 2, I get 32 equals x squared. A little work on my handy-dandy calculator, and I find that x is plus or minus 5.6569. Last step, look back at the original equation to check on our solutions. Whether x is positive or negative 5.6569, it gets squared before it gets logged, so both our answers are good. We have to check, though, because we can't take the log of a negative number. Let's go back to the other two examples. So if we use log x over 6 equals 2, we switch to exponent form, 10 squared equals x over 6. And of course now we can solve. 10 squared equals 100. And if 100 equals x over 6, then I think 600 equals x. The other example I had going was natural log of the group x minus 5 equals 2. So again, we've switched to exponential format. We've got e squared equals x minus 5. I'm going to add 5 to both sides to solve for x. And I'm going to need to do some evaluating with my calculator, which tells me that e squared plus 5 is approximately 12.3891. Since both of those answers were positive, I didn't have to worry about eliminating extraneous solutions. But what if we have more than one log expression in our equation? Before we can work on that, there are three properties we should review. They're going to come in very handy. The first property is about adding the exponents when you're multiplying. In log form, it looks like this. Log base b of m plus log in base b of n is equivalent to the log in base b, that's b, of m times n. Now I know to some of you that looks like math gibberish. So here's a more concrete example of how we might use this. If we have log of x plus log of 5x, we can rewrite that as log of x times 5x, which equals log of 5x squared. The second property is the related one about subtracting exponents in a division problem. So log base b of m subtract log base b of n equals log in base b of m divided by n. A useful example of that could be that the natural log of 2x subtract the natural log of the group x plus 3 could be rewritten as a single natural log of the fraction 2x over x plus 3. The third property is the one about multiplying powers. When you raise a power to a power, n times log in base b of m is the same as log in base b of m to the n power. An example of that in use would be if we had 3 times log base 5 of x, we could rewrite it as log base 5 of x to the third. These properties sometimes get used to expand logarithmic expressions, but we're going to use them to condense expressions, like I did in the examples. We are going to take expressions with multiple log pieces and squish them into single logs. If we can squish them, then we can switch them, and we can solve. Ready for an example? How about log of x plus log of the group x plus 1 equals 3? I see that I have 2 logs that are added, so I'm going to do my squish with multiplication. Log of x times x plus 1 equals 3. And I'll use a little distributive property to clean that up, so log of the group x squared plus x equals 3. Now I'm ready for my switch. So here we go. 10 to the third power equals x squared plus x. And now we're ready to solve. 10 to the third is 1,000. So ladies and gentlemen, it looks like we got ourselves a quadratic. 0 equals x squared plus x minus 1,000. But you already know how to solve quadratics. What's your favorite method? I don't think this one is factorable, so I'm thinking I'm going to go quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a, which is going to get me negative 1 plus or minus square root 4001 on top of a 2. Now, your teacher might prefer simplified radicals, but I'm going to use decimal approximations. So when I take out my calculator, I evaluate this and I get that x is either positive 31.1267 or it's negative 32.1267. So I go back to my original equation and I see, I've got to log my x, so I am going to dump the negative 32 and change and say that x equals 31.126. Ready for another one? Natural log this time. 2 ln x subtract ln 4x is equal to 3. So I'm going to squish. And the first thing I'm going to do is give the 2 to the x as an exponent. And then I'm looking at a subtraction, so I'm going to combine them into a single fraction. Ooh, bonus, I can reduce that fraction. So when I'm all done squishing, I have natural log of x over 4 equals 3. That means it's time to switch. So I'm in base e to the third equals x over 4. And solving it, I've got to multiply by the 4. So 4x e to the third equals x. And that's going to take some calculator evaluating. And when I punch that in, my calculator tells me that x equals 80.342-ish. I checked that in my original equation, and I'm good. So, next time you have to solve an equation with logs in it, squish if necessary, switch, and solve. It works every time.